So let's talk a little bit about how these addresses get applied. We talked about all the types of addresses. How do we get an actual address on a node in our environment? First off, there's two ways. There's manual and dynamic. Those are our two ways that we can have addressing. First off, there's the static or EUI64, okay, for manual, meaning I'm either going to statically assign it or use EUI64. We also have IPv6 unnumbered. That means we can use a router with the IPv6 address command in order to get that done. Next up, we have dynamic ways. So, like I said, this is on a router. If we're going to do this on a router interface, we can use the IPv6 address command to assign an IPv6 address to that router. And then that router is going to advertise it out when we can use static or EUI64 from there. Dynamic means we're going to use stateless auto configuration or SLAC, and we're going to use this for EUI64 or a completely random address here. Or we can use DHCPv6, so version 6 of this, in a stateful or stateless configuration. We'll give you more on that in a little bit. But these are the ways that we can do an assignment here. So manual with the static or EUI64. Remember, on a router, that's an IPv6 address command with our address at the end there. So lots of ways to do this in our environment. In our dynamic setup, it would be an IPv6 command with the unnumbered command after that. So this is what it would look like for our router. Our router was here, pound sign for config mode, and then IPv6 unnumbered. Of course, you would be at the interface level for that command. I just ran out of room to type in my interface. So big difference here between our manual and dynamic in our environment. All right, so let's talk about the SLAC process, stateless address auto configuration. Now, first off, SLAC uses EUI64 to select an IPv6 address. So we start at the router level. That's where we start at. We're going to start at the IPv6 router level. This is the configuration of the interface for this particular local area network. Now, this is going to come out with a router advertisement and says, hey, look, guys, we are using the 2001 DB8020 :64 network. This is our network, and you can see that here. If we look, this is the first 64 bits of that address. That means the rest in here, that's assignable by you. Go for it. Do whatever you have to do. The clients receive this router advertisement down to them. So this is received here at the client level. Both clients receive this. And then the clients do what they want to do. They self-assign addresses based on the router advertisement. So you can see here, this laptop shows 3, this laptop shows 2. Now what happens at that point is DAD, the duplicate address detection, make sure that no other node within this local area network from this router on down has the same IPv6 address. Much like we would see in an IPv4 environment, duplicate addresses just don't work here. It would very much disrupt communication. So again, the client self-assigns this address. So this portion right here is part of the router advertisement, right? Then we simply append this portion, we self-assign what the remaining portion is going to be, the identifier for this network. Now that was one form of stateless configuration of IPv6. Here's another stateless configuration. If we have DHCP version 6 running, we can use this DHCP server to provide addresses for all of the nodes in our environment. This works exactly like it would in IPv4. Now, if we're using Slack, if we use Slack, there's really no need for this setup, is there? If we're using Slack, there's no need for it because we don't need the DHCPv6 IPv6 server to provide our IP addresses. The clients are going to self-assign based on that initial router advertisement. We learned that in the last slide. But what we can do in stateless is we can say that the DHCPv6 server is going to provide information that our router advertisement just didn't carry, like our DNS domain, our DNS server. All this type of information that was not included in our router advertisement, we can now include, including vendor options. We have any vendor options we want to include, 43 or 48 or some of those custom options where we can send additional information to the clients through the DHCPv6 server. So there's really two ways we can do this, stateful and stateless. With the stateless, we can rely on Slack to provide the router advertisement and get the addresses, but this additional information down there we can provide with that DHCPv6 server. Now, what about the stateful DHCPv6 server? The stateful DHCP6 server provides a little bit more connectivity. Like I mentioned in the last slide, we can set this up. Remember, this last slide, we talked about stateless DHCPv6. That means we use Slack still here. Slack here, we still have the router advertisement that goes out. But after that's done, after the addressing has already been completed, we're going to request additional information from the DHCPv6 server. Like I said, DNS, DNS name, all that stuff. That's stateless. Stateful with the DHCPv6, like I said earlier in that last slide, was this is just like IPv4 now. We can not only get all that information, but we are also going to assign the addressing too. The addressing is no longer coming from the router advertisement of the router. The addressing itself is coming from here, from the DHCPv6 server. We are not going to self-generate. Self-generate? No. That was a Slack setup. We're not using Slack anymore. This is stateful DHCPv6 in use. Very, very interesting setup.